Welcome back. In this video, what we're going to do is we're going to explore the concept, the connection between the definite integral and the area. Remember that the definite integral means area under the curve. So like in this first example, what happens is if I have 2x plus 1 as my integrand, I drew that 2x plus 1, which is just a line over here, and I want to evaluate the integral from 0 to 3 of 2x plus 1. Well, that just simply becomes a trapezoid is all it is. And so my delta x is going to be 3. That's going to be the height of my trapezoid. And then the bases are going to be 1 unit on that side, and we're going to be 7 units on the right side. So this area, which is this integral, is going to be 1/2 of 3 times 1 plus 7, or 12 units. Sometimes these equations can get a little bit tricky, or they'll give you pictures that are a little bit tricky. So like in this next one, f of x is 1 plus the square root of 4 minus x squared, and I want to evaluate the integral from 0 to 2 of f of x dx. Well, it's this area that's bound by the x-axis, so it actually comes down here. Let me just sketch those in. It comes down here, and then it comes down here. And it's that area that's bound by this graph, whatever it may be. And so we have this rectangle, which is 1 unit high. It's 4 units wide. And then I have this semicircle. It's above the x-axis, so it's all positive. So it would be 1 times 4 on the rectangle plus the semicircle, which has a radius of 2. So 1/2 of pi 2 squared. So in this case, it would be 4 plus 2 pi. And then sometimes what you're going to see is that we'll give you drawings, and when we give you the drawings, sometimes the drawings are a little bit complex. And this is my derivative graph, f prime of x, and I want to take the integral from -5 to 5, which is find the area that's bound right here. So it's bound here with this triangle, this semicircle, and then this triangle, which are the same. The triangles on the outside are the same. And the one little trick on this one is that this circle, this semicircle, is below the x-axis, so it's got to be considered negative, or you got to subtract it away. So with the triangles, since there's 2 of them, I'm just going to double it. So it's going to be 1/2. I think the base of that is 3, and the height is 2. And then I'm going to add to that the area of the semicircle, which is negative because it's under the x-axis, and then that's 1/2 of pi times 2 squared. So ultimately, I get 6 minus 2 pi. Sometimes that area gets a little bit more tricky, a little bit more complex, takes a little bit more work to divide it up. All right, we'll take a look at a few more examples in class. Good luck. See you soon.